All right, this is our second video on Engage New York, Module 2, Lesson 14, Converting Rational Numbers to Decimals Using Long Division. What we saw when we just finished the first page yesterday, we saw some patterns in different fractions, or when we divided different numbers. When the divisor, or the denominator, was was made up of multiples of 2 and 5, then it was a decimal that stopped. It did not repeat. If it had anything else, like if it was odd or if it was multiples of 3, then it was repeating. But the key thing is none of these have denominators made up of factors of 2 and 5. Yes, 15 is a factor, or has 5 as a factor, but it also has 3 as a factor. Whereas 20 is only 2 and 5 as factors. So that's why that one is a non-repeating, and this one is a repeating. So we came to some really great conclusions in our last video. And now what we're going to do, we're going to put our calculators away. Just set them off to the side. Because now we're using the long division algorithm. We're no longer going to be just using our calculators to type in 3 divided by 4. We're going to go back to 4th grade and do that long division algorithm. Now, one of the things that's going to be, it's not really confusing, but you might say, well, I don't know how to do it with negatives. And you don't really need to worry about necessarily doing it with negatives. What you do need to understand is that this is a negative number. So negative 3/4, even when I find the decimal approximation, is still going to be negative. That way we can focus on just the 3/4. Now, this is 3 divided by 4. Yes, Carter? Great. You can also think of it that way as well. I'm glad that you're making that connection to our integers unit. We can think of this as the opposite of 3/4 instead of just negative 3/4. Really great connection to make. So really, we have 3/4, which I want you to understand is 3 divided by 4. When I'm setting up the long division algorithm, which way does it go? I see a lot of students making mistakes, even this age group. Does it go like this? Or does it go like this? Which long division, which is the correct way of setting up that long division? Talk with your groups if you don't know. Okay, which is the correct one to use? Dylan? Yeah, the top one. And at some point you're probably going to make a mistake, so it's always good to check it. We know that 3/4 is less than 1, right? So we don't even have a whole pi here. So if I were to do this and I say, can 4 go into 3? The answer is no, it can't, 0 times. But if I do it incorrectly, can 3 go into 4? 1 time. Which one makes the most sense, knowing that 3/4 is less than a whole? Does this one really make sense? Okay, so always check your answer before you go on. Check to make sure it actually makes sense. So let's continue on with this one. Can 4 go into 3? No, it goes in 0 times. So I put a 0 there to acknowledge that we answered that question, no. But we don't just stop there saying, nope, can't do it. We bring in that decimal and we annex a 0. And now we ask the question, can 4 go into 30? Can 4 go into 30? How many times can 4 go into 30? 7 times. I was trying to get all the way up to 30, but 4 7 times only gets me to 28, so I got close. Not quite close enough. How far away am I? 2 away. And now I have a remainder, so that means we're really truly not done. Maybe back in 4th grade we were done, but now that we're grown-up 7th graders, we annex another 0 and we keep on going. Can 4 go into 20? It can. How many times? 5 times. I was trying to get to 20 and I made it to 20. So can I be done now? I can be done. Yep. So negative 3/4, or the opposite of 3/4, is equal to negative 0.75. Again, don't let that negative bother you. It's there in both versions of that. Your turn. Parts A and B. I want you to convert each rational number to its decimal form using long division. We're going to pause the recording so that you can give this a try. Come back to check your answer. Pause the recording now. All right, let's do these. This -7/8, what that really means is -7 divided by 8. So I'll be setting that up asking how many times can 8 go into 7? And again, I am recognizing 7/8 is less than 1, so it should be less than a whole. Can 8 go into 7? No, so that means I've set it up right. Annex a 0, or bring in that decimal point, annex a 0. Can 8 go into 70? Yeah, it can. How many times, Luke? 8 times. So 8 times is 64. I was trying to get up to 70. I only made it to 64, so I missed it by 6. I'm 6 away. So we annex another 0, and we ask again, can 8 go into 60 this time? It can go in how many times, Trace? 7 times. So again, I was trying to get up to 60. I only made it to 56, so I'm 4 away. So we annex another 0. Can 8 go into 40? Yes, it can. 5 times. I was trying to get up to 40. I made it to 40. I've got nothing left finally, so I have 0.875, or said the proper way, 0 and 875 thousandths. Yes, Joshua. Good catch. I was going to see if anyone was going to math practice 6. You did it. -7/8 is equal to -7 divided by 8, which is equal to a -0.875. Math practice 6, attentive precision. We started with a negative. We want to make sure that we end with a negative. Anyone else catch that? Did you make that mistake on your own page? All right. Okay, let's learn from that. B, 3/16. That is the same as 3 divided by 16. So I'm asking, how many times can 16 go into 3? All right, there we go. Can 16 go into 3? Nope, 0 times. So bring in that decimal and annex a 0 and ask again, can 16 go into 30? Yes. How many times? 1. Yeah, just once. I was trying to get all the way up to 30. I only made it to 16, so I'm quite a bit a ways. I'm 14 away. So now, can 16 go into, annex a 0. Can 16 go into 140? It can. At this point, if you needed to use your calculator here, I would accept that. I don't want you to use the calculator to do 3 divided by 16, but if you needed to figure out how many times 16 can go into 140, I will accept that. How many times can 16 go into 140, Carter? 8 times, exactly. And 8, 16 times, again, you can use your calculator here. 8, 16 times. Carter, again, just because I know that you have it done. 7 times. Whoa, 7 times? 8, 16 times. What do we get? There we go. Yeah, 128. So I was trying to get up to 140. I got close. I got 128, but unfortunately, I'm still 12 away. We can always check. This is a good place to check. Can 16 go into 12? No, it's not supposed to be able to. If you ended up doing it incorrectly and you said yes, you would be able to check it here. But 16 can't go into 12. That means we're doing it right so far, so we can bring down another 0. Can 16 go into 120 now? Yeah, how many times? Bella? 7 times. So 16 7 times is equal to, thank you, Bella, 112. Getting closer. I was trying to get to 120. I got to 112. I'm still 8 away. Annex a 0. Bring it on down. Can 16 go into 80? Oops. It can. How many times, Oren? 5 times. 16 5 times is what, Oren? Oh, thank goodness. Right? Weren't you guys feeling kind of relieved there? Did you feel like maybe it was going to be repeating and go on forever? It was lasting a long time. But you shouldn't have felt that way, should you? Let's look at that denominator. 16. What are the factors of 16? 4 and 4, right? What are the factors of 4 and 4? 2 and 2. Do we have any other factors besides 2? No? Well, but what are the factors of 4? 2 and 2. So again, are there any other factors besides 2? And yes, 1, but 1 is a useless factor for the point that I'm trying to illustrate. So, really, truly, based on what we saw here, we should have been able to conclude that it was going to repeat or stop eventually, right? All right, good job. And now let's look at our next examples. Let's use long division to find the decimal representation of this. 1 divided by 3. 1/3 is 1 divided by 3. Why, Trace? Why don't you want to do this? It's going to go on forever, exactly. We already know that. And how do we know that? Let's use what we did in our last video. We know that 1/3 is a repeating decimal, right? Why do we know that? Because the denominator is a multiple of 3. It is 3, so it's a multiple of 3. So we already know it's going to be repeating. So what we're going to do on this one is once we start finding and recognizing that repetition, let's maybe stop instead of going on forever and forever and forever. So we don't have to be overly concerned. We're going to do it just a little bit, probably a little bit longer than you want to, but not super ridiculously long amounts of time. Yeah, exactly. Yeah. So can 3 go into 1? Try again. It better not be able to. 3 cannot go into 1. So it goes in 0 times, bring in that decimal, and that's annex a 0. And now let's ask again, can 3 go into 10? Yes, it can go in 3 times. 3 3s is 9. I was trying to get to 10. I'm 1 away. So we annex a 0, bring it on down. Can 3 go into 10? Yeah, we already answered that question, right? Can go in 3 times. Let's just do it one more time. I was trying to get to 9a, or trying to get to 10, only made it to 9. I'm 1 away. So we annex that 0 again. Can 3 go into 10? The answer is still yes, and the answer is still it can go in 3 times, and we can see that this process repeats, right? So, what do we do at this point? Once we find that repetition, we write 1/3 is 0.333 ... because we know that this process is going to continue. But you are sophisticated junior high students now, so we don't just write ... and we don't write 0.3 or 0.33. You guys all have your hands raised because you know. What do we do? Liv? Yes, overbar. The overbar indicates that that digit is going to repeat. Okay? So I want you to practice this with exercise 2. On both parts A and B, you're going to see that they are repeating decimals. Let's figure out why. What are the factors of the denominator? What are the factors of 9? 3 and 3. What did we learn? If it's a multiple of 3, it's going to be repeating. Let's look at the next one. 11. Odd number, yes. But again, one of the things that I want you to look for, the factors of 11 are 1 and 11. Is it a 2 or a 5? Automatically. So you don't even have to worry, is it odd? Is it a multiple of 3? Are the factors only 2 and 5? If yes, then it's going to stop. If no, it's going to repeat. So just keep that in mind. And now, do you guys need my help? I don't think you need my help. Do what it says. Express your answers using bars over the shortest sequence of repeating digits. I'm going to see if you guys can figure out what that means. We're going to go over it in the video together after you give it a try. Pause the recording. Ready, set, go. All right, let's go through these. Again, I see this negative, so I know that for sure once I do this long division, my result is still going to be negative, even if I'm going to ignore it for now. What I'm asking is, how many times can 9 go into 4? I know 9 can go into 4 0 times. Bring in that decimal and annex a 0. 9 can go into 40 4 times. 4 9s is 36. I was trying to get to 40. I only got to 36. There's 4 left over. So we annex a 0. And I'm back to where I started. Can 9 go into 40? Yes, we already know the answer to that. It's 4. And how about that? We're right back to where we started again. Right? So we know, we can see at this point, that process is going to continue to repeat. Can 9 go into 40? Yes, 4 times. So stop. Recognize that repetition. And now we are going to write it as 0.444 ellipses. It repeats. But the best way to write that, what is the digit that's repeating? It's the 4 that's repeating. So I write it with the overbar over the 4. I only write it over 1 4. This 0.44, that's unnecessary, right? Because it's just the 4 that's repeating, so if the 4 is repeating, the next one's going to be a 4, and that is redundant. Yes, Carter? Ah, good catch. That time I did not mean to make that mistake, but you caught me regardless. Math practice 6, nicely done. Good job. Okay, and same thing. I'm not going to forget this time. This is going to be equal to a negative. And I'm asking, can 11 go into 1? Nope, 0 times. Bring in the decimal and annex a 0. Can 11 go into 10? No, still a 0. Bring in another decimal. Can 11 go into 100? Yeah, 9 times. 9 11s is 99. I was close, just 1 away. So I need to annex a 0. Can 11 go into 10? No. So annex another 0. Can 11 go into 100? It can. How many times? 9 times. Did you catch that repetition? Kind of interesting, isn't it? So we see that this is going to repeat, right? And now we have negative 1/11 is equal to negative 0.0909. What is the part that's repeating? It's the 0.9. So I write the, oh, I almost forgot. I didn't really mean to do that. There's my negative. 0.09. The 0.9 is what's repeating, so the overbar goes over both the 0 and the 9. How'd you guys do on that one? It's not too bad, is it? Okay, C and D. Pause the video again if you need some extra time to get these ones done. Let's do C and D. All right, and now that you have had a chance to do these ones yourself, let's do them together. 1/7. I'm asking how many times can 7 go into 1? The answer is 0. Annex that 0, bring in the decimal, annex a 0. Can 7 go into 10? 1 time. 1/7 is 7. Trying to get to 10, I was at 7, that means I'm 3 away. So we annex a 0, bring it on down. Can 7 go into 30? It can. 4 times. I know, you already see what's going to happen, huh? 4 7s is 28. So I'm 2 away. Annex a 0. Can 7 go into 20? Yes, it can. 2 times. It is going to be repeating. I'm glad that you recognize that. It is going to be a repeating decimal. I know that because 7. 7 doesn't have factors of only 2 and 5. The only factor of 7 is 7 and 1. So it is going to be repeating, but man, I haven't seen any repetition yet, have you? Yeah, let's keep going. I was trying to get to 20. I only made it to 14. I'm 6 away. Annex a 0. Bring it on down. Can 7 go into 60 this time? Yeah, 7 can go into 60. 8 times. Man, that hurt my brain. 8 times. I was trying to get to 60. I only made it to 56. 4 away. Can 7 go into 40? Yes, it can. Oops. 5 times. 5 7s is 35. 5 away. Annex a 0. Can 7 go into 50? Yes, it can. Oops. 7 times. I didn't leave myself enough space. Did you guys leave yourself enough space? Me either. Technology. I am. All right, can 7 go into 50? Yes, it can go 7 times, so 49. 1 left over. Oh, finally. It's back to 1. Can 7 go into 10? It can. 1 time, we're back to 1. And we can see that that process is now going to continue. That's a lot of repetition, right? But didn't we already know that? Remember this guy all the way at the beginning? We saw it. 1/7 is 0.142857. 142857. So we knew it was going to be a long one. Oh. It's all right, we survived it. How are we going to write this then? 1/7 is equal to 0.142857 with an over, or not over, I don't need that last one. That last one was the second repetition. The overbar goes over 6 digits that time. Yep, because all 6 digits repeat. Exactly. And I see a negative, so I know it's going to be negative. I also see it's going to repeat because 6 has factors of 2, yes, but also 3, which means it is going to be a repeating decimal. Yeah, do put this one high, maybe. Angle it, yeah, create more space that way. Can 6 go into 5? Nope. Bring in that decimal. Annex a 0. Can 6 go into 50? Ah, that one hurt my brain too. 8 times? Okay, thanks. 48. Trying to get to 50, only made it to 48, so now I'm 2 away. Annex a 0. Can 6 go into 20? Yep, 3 times. 3 6s is 18. 2 away. Oh, thank goodness. Do you guys feel that relief now too? Yeah. 6 going to 20. 3 times. We see that repetition now. Put those ellipses there too. So we end up with negative 5 6 is equal to negative 0.83. Where should that overbar go? Yeah, just over the 3. The 8 is not repeating. Only that 3 is repeating. So we only put the overbar over the digit that repeats, which is the 3. Okay. How do we determine whether the decimal representation of a quotient of 2 integers with the divisor not equal to 0 will terminate or repeat? Summarize what we've seen. Summarize what we talked about on that very first page. If I have just a fraction like 1/7 or 1 divided by 7 or 5 6, 5 divided by 6, how am I going to know if it repeats or if it, here's a new word, terminates? Let's go back to that front page and let's label that decimals that stop. Let's call it terminating decimals. It is a big fancy word. It's a big fancy word that means it stops. Yes, yeah, I was wondering if anyone would make that connection. Does anybody know the Terminator? You guys are way too young for that. Even I'm honestly a little bit too young for it. So if I'm too young for it, you guys definitely are too young. You know that famous line, "I'll be back." You guys don't even know the line. That's so disappointing. Okay. Okay. So, summarize everything that we've done so far. How do we determine whether the decimal representation of a quotient of 2 integers with the divisor not equal to 0 will terminate or repeat? Basically, when I look at the denominator, how do I know if it's going to repeat or not? Talk with your groups real quick, please. Okay, how do we know if it's going to terminate, meaning it stops, or it repeats? Just by looking at the denominator or the divisor. How am I going to know? Carter? Yes, I want to clarify that just a little bit. Look at the denominator / divisor and look at the factors. You're right, the magic things to look for in factors are 2 and 5. But not just if it has 2 as a factor, and not just if it has 5 as a factor, but if it only has 2s and 5s as factors. If the factors are only 2 and 5, it will terminate. For example, we saw this already. What if the divisor or that denominator is 15? What are the factors of 15? 5 is a factor, right? But it also has a factor of 3. So is it only 5s and 2s? No. So that means this one is going to repeat. So if the factors are only 2 and 5, it will terminate. Any other factors will repeat. Yes, Grant? Good, we'll get there in just 1 second. Yep. So 14 has a factor of 2, right? So we think, oh, that one's going to be terminating, but the other factor is 7, which is not 5. Therefore, that one's going to repeat. Great observation. So any other factor besides 2 and 5 will repeat. All right, it's time for some stories. Eric and his friends are taking a trip across the New York State Thruway. They decide to split the cost of tolls equally. If the cost of tolls is $8, how much will each person have to pay? Eric and 4 of his friends. So how many people are there altogether? There's 5 people, exactly. Eric and 4 friends, that's 5 people. So the cost of the tolls is $8, which we are dividing by 5. Is this going to be a terminating or a repeating decimal? Terminating, because the divisor is 5. So it's going to be a terminating. Yes, Carter? Okay, good. What we're asking is, can 5 go into 8? Yes, it can, one time. Annex is 0. Nope, we're not done yet. 5 can go into 8 5 times. Subtract 3. Now we can annex that 0 and bring it down. Can 5 go into 30? Yes, Mrs. Proctor? It can go in 6 times, leaving me with 30, and I'm done. So how much will each person have to pay? $1.6. What would we normally say, though, instead of 1.6? There we go. Yeah. $1.60. Just before leaving on the trip, 2 of Eric's friends have a family emergency and cannot go. What is each person's share of the $8 tolls now? Now, what are they going to do? Yes. Tell me, Luke. You could answer that way. However, since it's just saying what is the cost, we can just say the cost is $1.60, and that would still show that we understand that it's money that they're going to be paying or giving away. Good. Let's do this last one. How many people are there now? 3 people now. If 3 people, the divisor is 3, is this going to be repeating or terminating? Repeating. I don't want to do that, do you? We can do it, though. We're not afraid. We don't want to, but we can. Can 3 go into 8? 2 times. Annex that 0. Can 8 or 3 go into 20? Yeah, 6 times. And we see that 2 again. So, can 3 go into 20? Yep, 6 again. So how much is each person going to have to pay? Careful, it's not really $2.66, because if each of the 3 people only pay $2.66, they're going to be short a penny. Yep, right. So $2.66 for 2 people. Someone's going to have to fork up an extra penny. Do you see why I'm saying that? Because really, truly, this is repeating. But can we cut up that penny into pieces to now pay that extra part of a penny? Of course. And the teller at the toll bridge is definitely going to accept it too, right? Yeah, I wish. All right, we have now made it to the summary. The real world requires that we represent rational numbers in different ways depending on the context of a situation. All rational numbers can be represented with either terminating decimals or repeating decimals using the long division algorithm. We represent repeating decimals by placing a bar over the shortest sequence of repeating digits. Nice and easy, that's your summary. This is your problem set. So, complete this for homework. There's quite a few problems, but honestly, it's not going to be too tough. I promise that you'll be successful with these. I'm not going to let you use your calculator, but your brain is going to work really, really nicely. What is 1/3 as a decimal? 21. Try again. It's not 3/10 either. It's 0 and 3 over bar. Yep. So 0 and 3 over bar. And 2/3 is 0 and 6 over bar. So it's not going to be too hard. And we've done a lot of these throughout the packet, so you can also use what we've already done in the packet. Look for some interesting patterns. That's it for today's video. Thanks for watching.